Hi, I'm an old guy and I do maths, and today we're looking at two-step communication matrices. So the obvious place to start is with a one-step one. So what I'm going to do is I'm going to transfer the information on this matrix to a network, so you can see this in illustrated form, and then we'll deal with the business of the second step. So let's just have a look at how we do this. These are the points, the vertices from which we move, and these are the vertices to which we move. So A to A, there is nothing. A to B, there is nothing. A to C, there is 1. These are directional, so I put arrows on them. A to D, there is nothing. B to A, there is nothing. B to B, there is nothing. B to C, there is 1. And B to D, there is 1. So you can see how this is beginning to fill out. C to A, there is 1. Now, these note the direction in which the communication occurs. C to A, C to A, C to B, C to C, nothing. C to D. Bottom row, D to A. Now, I'll just run this around here so it's really clear. Okay, this is our communication network. Now, every one of these, D to A, B to D, C to B, B to C, C to A, and A to C, indicates a single step to communicate from, say, here to here. But you'll notice that if you wanted to communicate with A and you were at B, you could do the following. You could go to C and then on to A. That is the second step of communication. And the problem is as follows. You can get really, really tangled up in this, especially in a much more complex network. And so there has to be a way, you would hope, in which this can be simplified, and there is a way. And this is it. We take our original matrix and we square it. And when we square it, what we discover is that it's possible to find two-step communication. And this matrix, which is this matrix squared, looks very, very different. So let's just have a look at what's going on. So in the first matrix, this was A, this was A. There was no communication, there was no circle that got from A back to A. But if you look at this, you could go from A to C and back to A, two-step. So there is a single two-step communication path between A and A. Similarly with A to B, there was no direct communication from A to B, but you can go from A to C and on to B. And the same for D, A to C and on to D. So there is a two-step path from A to each of these three points, not C. But you'll note that in the first matrix there was direct communication to C. Anyway, on we go. So B to A. Well, you can get from B to C and on to A. That's one. You can get from B to D and on to A. That's the point of drawing that round there, so it's nice and clear. So there are two-step routes for communication between B and A in that order, and so forth and so on. But the key thing is that to get to this matrix, you square this matrix. Now, what does that mean? Well, for those of you who don't have the facility to square a matrix, but have plenty of time on your hands, because this is a laborious task, which I am not going to do it here. I'm just going to show you the basic idea. 0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, that's a 1, 1, 0, 0, 0. This squared means taking this and multiplying it by itself. And you either do it this way on a calculator, which is what I did, or you do it this way, longhand, which means taking this row and multiplying it by this column, and so forth and so on, until you get your two-step matrix. Anyway, that is how you create a two-step matrix. Now, just to go back and look at this from the start for one more thing. I started with a matrix and went to a network. But if I wanted to create this matrix from this network, what I would do is I would set this up, it would be blank in here, and I'd look at A and I'd say, is there a single communication path from A to A? No. A to B? No. A to C? Yes. There's one communication path, and so forth and so on. You can have a look on my video about communication matrices, the basics of them, to see how that's done. Anyway, this is a two-step matrix, which tells you all about the two-step paths of communication within this network. Thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.